Hello. In this lesson, we're going to look at sketching trig functions when we have some more transformations applied to them. For our first problem, we want to sketch the graph of y equals sine of 2 theta, and we'll do this one in degrees. Now, normally, if we were to sketch just y equals sine theta, as a quick refresher, we would go ahead and grab our 5 key points, which are at 0, 1, 0, -1, and 0, and are of course at 0 degrees, 90 degrees, 180 degrees, 270, and 360. So all of those numbers are our 5 key points that we should have memorized. We simply connect the dots, and we have our basic graph of sine. So what do we do if there's a 2 in front? Well, thinking back to our transformations, a value that's outside, so for example, a value like a 3 here, will affect the y values. A value on the inside, like the 2 we have, will affect the x values. Numbers that are added or subtracted outside are, of course, added or subtracted to the numbers, and numbers that are multiplied, of course, are multiplied to the graph. The only thing to keep in mind, of course, is that because the value we're looking at affects the x values, it doesn't affect them the way you might think. We're not going to take our x values and multiply them by 2. Whenever we do a transformation to the x values, we always have to do the opposite. So 2 theta implies that we divide the x values, or the theta values in this case, by 2. Or if you want to think about it, we can multiply by 1/2. All right, well, we have our basic graph here, and so we'll blow it up a little bit bigger. The y values will stay the same, so we've got -1, 1, and in some ways we can even get away with putting the same points. We can just put the points up here, and then just label the theta values at the very end. So instead of 0 degrees, we would divide by 2, which would still give us 0 degrees. 90 degrees would divide by 2 and give us 45. 180 would give us 90. 270 would give us 135. And 360 would give us 180. So all we have to do now is label our x values: 180, 135, 90, 45, and 0. Connect the dots. And if you wanted, we could add some arrows because we know the graph does continue on. For this problem, it probably would say something like sketch 1 period of the graph. And so there's 1 period of the graph, and we're good to go. Now let's try an example with 2 transformations. Here we have cos, and we have it in radians. Notice we have a transformation on the theta values, or the x values, and we have a transformation on the y values as well. So again, it's best to start with the basic graph of cos, because that's what we're going to be transforming. We know that for cos, we start up at 1, then we go to 0, -1, 0, and 1, with a nice valley shape like that. And the values, because they're in radians, we know they end at 2 pi. They start at 0, and so it goes 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, well, all we have to do is take the 4, which means the y values, get multiplied by 4, and the 6 means the x values, well, because it's the x value, in this case, multiply by 6. Okay, so we can again set it up like we would a regular transformation. We can put our original values here, sort of like mapping. So we have 0 and 1. We have pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi, and 1. Now for each one of these, we need to do something to the x and the y. The x values we have to multiply by 6. So if you want, you can do all of those first. So 0, pi over 2 times 6 will be 3 pi, 6 pi, 9 pi, and 12 pi. Then we can multiply the y values by 4, so we get 4, 0, minus 4, 0, and 4. And then we simply take those new points and we go ahead and graph them. Again, we're going to want to label everything on our new axis just to make sure that, I know we have the points written here, but it's nice to have them labeled. So up here we'd have a 4, down here we have a minus 4. Again, we know it goes top, middle, bottom, middle, and top. And these are going to be 3 pi, 6 pi, 9 pi, and 12 pi. All right, connect the dots. And of course, for the cos graph, we know that it curls back down on either side because it's going to continue with that cos wave. Now, how about something like this, where we have a negative 3 sine 3x minus 4? Again, we want to do it in radians. Well, we have to take each transformation under consideration. The negative 3 in front, that's going to be to the y values, and we're going to multiply by negative 3. And then negative 4 is also to the y values, and we're going to subtract 4. Then the 3x, I'll do that in another color, we're going to divide the x values by 3. All right, we have the sine graph as our basic graph. Now you don't technically have to sketch the sine graph. If you know the points, you can just go writing down the old points and the new points for your mapping. You may just even give yourself a quick sketch like this and then start writing the points. That's totally fine. The main thing is to get these points. The 0, 0, pi over 2, 1, pi and 0, 3 pi over 2, negative 1, and 2 pi and 0. We just need to have our old points handy so we can do the transformations. All right. So again, when you're doing the transformations, you could do the x values first, the y values first. It doesn't really matter. Do them both at the same time. I like to do all the x values first. So we have to take all of our x values and divide them by 3. So 0, pi over 2 divided by 3 will be pi over 6, pi over 3, pi over 2, and 2 pi over 3. Just watch your fraction work there. For the y values, we have to multiply by negative 3 and then subtract 4. Remember to do all of your multiplication first and then your subtraction. We have to do the transformations in a specific order. So 0 times negative 3 is still 0, subtract 4 and negative 4. 1 times negative 3 is negative 3, subtract 4 is negative 7. Negative 4. This will be positive 3 minus 4, which is negative 1. And then another negative 4. All right. Go ahead and set it up. And we've got our largest point. Well, actually, maybe when we draw this, we might want to draw our axis sort of like this, because our highest point is actually up at negative 1. And then our middle point is down at negative 4, and the lowest point is at negative 7. Okay. Then we have our x values. You can just kind of evenly space them. So pi over 6, pi over 3, pi over 2, 2 pi over 3. And then just put the dots where they're supposed to go. So here we would have 0 and -4. So the first point, I'll do another color, would be down here. Pi over 6 and -7. Pi over 3, -4. Pi over 2, -1. And back to -4. Then we connect our dots. Oh, let's try that again. Try to make your graph nice and smooth. Then we can throw some arrows on the end. Now, if you look here, compared to our original graph, the new graph looks a little different, right? The sine graph usually goes up and down. This one goes down and up. That's, of course, because of this negative sign. The negative sign has created a vertical reflection, so that's why the graph looks reflected. But you don't have to know that ahead of time. As long as you just follow the mapping, all of your points will line up and you'll be good to go. All right, let's look at a real doozy here. We've got y equals 4 sine bracket pi over 2 bracket x minus 3 close bracket plus 2. My goodness, this has almost all the transformations. And so I'd encourage you to pause the video and give this one a try. See if you can get the correct mapping for all the points. All right, hopefully you gave this a try. Again, we'll just start with our basic sine graph and we'll grab our basic points. 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2, -1, 2 pi and 0. Now for this, we have to do a lot of math on each one of the points. The 4 and the +2 are the y values. So we're going to multiply, this is for the y, multiply by 4, and then we're going to add 2. So first multiply by 4, then add 2. For the x values, let me do that in another color here. For the x values, we are going to, ooh, this is weird, pi over 2. So we are going to multiply by the flip. So multiply by 2 over pi, and then the -3 actually becomes a +3. So we'll add 3. Whew, okay, so when I'm doing the points here, I think it's going to be easiest to do the y ones first. So let's try with the easy ones. Let's get the y points out of the way. 0 times 4 plus 2 is just 2. 1 times 4 is 4 plus 2 is 6. 2. -1 times 4 is -4 plus 2 is -2, and then back to 2. All right, those are pretty easy, but the x values, they're probably going to need a little work on the side. 0 times 2 over pi, that doesn't do anything. It's just 0, and add 3 will be 3. But what about the pi over 2 times 2 over pi? So pi over 2 times 2 over pi. Well, that all cancels out and just gives us a 1. So when we add 3, we get 4. Okay, that's kind of weird. Let's try the next one. Pi times 2 over pi. Oh, that'll just be 2, and then 2 plus 3 is 5. Okay, maybe I'm getting the hang of this. 3 pi over 2 times 2 over pi. The pi's cancels, the 2 cancels, and we just get 3. 3 plus 3 is 6. All right, last one. 2 pi times 2 over pi. The pi's cancel, and 2 times 2 is 4, plus 3 is 7. Now, if you notice, these values here no longer have any pi's in them. Because there was a pi in our transformation, that pi kind of canceled out with the original pi values. And so now you just have like whole numbers, which on one hand is kind of weird, but for sketching it actually makes it kind of fun. You don't have to worry about any pi numbers, you just have regular numbers. So let's go ahead and give this a try. Let's label our y-axis. We've got a 6, a 2, -2. And for x, we've got 3, 4, 5, 6, and 7. All right, here we go. Let's get our points down. So 3, 2, 4, and 6, 5, 2, 6, -2, 7, 2. Connect the dots. And we're good to go. All right, we've got one more big one to try here. 1/2 cos 2 pi times x plus 4 plus 2. So again, I encourage you to pause the video, give this one a try, see what you come up with. All right, so we start with our cos graph. Grab our original points for cos, 0, 1, pi over 2 and 0, pi negative 1, 3 pi over 2 and 0, 2 pi and 1. Now for each of these points, again, we're going to have to do a lot of work to them because there's a lot of numbers there. The 1/2 and the 2 are the y values. So we're going to have to multiply by 1/2 and add 2. Maybe I'll put a dot there. Looks silly with the times as an x. For the x values, we're going to have to divide by 2 pi. And then we're going to have to subtract 4. Again, we have to reverse what we would normally do because the x values are always reverse. All right, let's do the y values first because those are easier. So 1 times 1/2 will be 1/2 and then plus 2. That's still not super fun. Let's do the fraction over here. 1 times 1/2 plus 2. So 1/2 plus 2, which we could make them common. So that would be 4 over 2. So 5 over 2. The 0 will be easy. That'll just be 2. This one will be 3/2 when you work it out. Back to 2 and 5 over 2. Okay, how about for the x values? First one's easy, just -4. When we divide by 2 pi, let's see. Pi over 2 divided by 2 pi means we have pi over 2 times 1 over 2 pi. The pi's cancel, and we get 1/4. Then we have to take that number, 1/4, and we have to subtract 4 from it. So that's 1/4 minus 16/4, so -15 over 4. Ugh, it's not the nicest number I've ever seen, but we'll just make it work. Let's do pi divided by 2 pi. So it'll be pi times 1 over 2 pi, which will be 1/2. Now we do 1/2 minus 4, which is 1/2 minus 8 over 2, -7 over 2. 3 pi over 2 divided by 2 pi. That's going to be 3 over 2 times 1 over 2 pi. So 3 over 4. Then we got to do 3 over 4 minus 4. So we get 3 minus 16, so -13 over 4. It might have been easier to keep these all over 4, but we'll make it work. One last one. 2 pi divided by 2 pi will be 1. 1 minus 4 is -3. All right, at least the last one was nice. Let's go ahead and take those points. And we'll get something like this. So the y values are between 3/2 and 5/2. And the x values start off at -4, then -15 over 4, -14 over 4, -13 over 4, and -3. Now some of you might argue, well, Mr. Peters, it doesn't look like the -4 to the -3 would make it all the way to the 0. It looks not to scale, and that's not really the end of the world. As long as your points are properly labeled, scale is a little subjective, and it's not really the most important part of the graph. So let's go ahead and we can put down our points. -4 and 5/2. -15/4 and 2. -14/4 and 3/2. And then back to 2. And back to 5/2. Now again, we want to be careful. We don't just want to connect it like this. Both cos and sine always have a bit of curvature to them, so drawing straight lines like this would definitely lose you marks. You want to give it that nice curvature that goes up and down. That looks like a wave. You can add a couple arrows and then you're good to go. All right, just in terms of the notes on this section, again, it's kind of like what we've been working on, just graphing trig functions, but now we have just more transformations. So with transformations, and technically here we have all the transformations. So we have y equals a sine b x minus c plus d. So each one of these represents a different transformation. The a and the d are the y values, and the b and the c are the x values. Of course, here we multiply by a and we add d. Here we multiply by 1/b and we technically add c even though it's being subtracted. So then that way if it was plus a c, we would subtract the c. I'll leave you just for the example. You can choose one, either choose one from the worksheet or go ahead and make up your own graph. You're welcome to just take a y equals and do sine or cos, pick some random numbers you want, and then just go on Desmos and type it in and check it. Make sure that the points you have are lining up with the points on the graph. All right, hopefully you enjoyed this video, and as always, thanks for watching.